Marine environmental indicators for the marine community. The environmental information available in the marine data infrastructures can be analyzed to produce new added value data and indicators. This way, we can observe the status of the environment, find the anomalies, and highlight the new trends. By improving our understanding of the marine environment, we can support the decision-making process for a healthy ocean and contribute to the development of a sustainable blue growth. From the Internet access link, it is possible to reach the public web page of the service and log into Marine Environmental Indicators Virtual Lab. Inside the VLab are present several functionalities, such as a user application and the development notebooks. With the application MEI generator, it is possible to select the desired output field, the associated input parameters, and the geographical domain of interest. When the information is ready, it is possible to proceed with the submission of the job. The new job will appear inside the My Data section with the associated progress status. At the completion of the job execution, it is possible to access the output data for the downloading and the visualization. The ocean patterns and ocean regimes indicators are an easy way to apply machine learning classification methods to oceanographic data. They have been developed in the form of Jupyter notebooks. You can find them in the VLab shared folders. The workflow is structured into two notebooks, a model development notebook and a prediction notebook. The objective of the prediction notebook is to load a model, classify either ocean profiles or time series into clusters, and to plot the results. First of all, you should choose your model. You can use an already trained model available in the Models folders, or you can design and train your own using the development notebook, where you can optimize the model parameters, for example, the number of classes. In these example notebooks, sample datasets are downloaded from the Copernicus Marine Environment Monitoring Service. The model will classify the data depending on their vertical similarities for the ocean patterns indicator, or depending on their seasonal variability similarities for the ocean regimes indicator. Some useful statistics are also calculated. Results are presented in multiple figures: a representation of the vertical structure of profiles in each class, the spatial distribution of classes which can reveal geographical coincidences or patterns, the robustness of the classification, a pie chart representing the data distribution into the classes, and the temporal distribution of classes that can reveal over other kinds of patterns. Some classes are more common in winter months, for example.